In this day and age of increased global connectivity, Honeywell SATCOM systems provide passengers and flight crews with worldwide data and voice communications, both in the air and on the ground. The SATCOM system includes the aircraft earth stations, the communication satellites, and the ground earth stations. These three segments make up the SATCOM circuit and serve as the communication link between the ground and the aircraft.
The space segment is the communication satellites. They provide a line-of-sight link between the aircraft and the ground stations. The satellites are maintained by the International Maritime Satellite Organization, Inmarsat, out of London. Inmarsat maintains a constellation of I3 and I4 satellites.
The Inmarsat I3 satellites provide standard voice communications and low-speed data coverage for the Atlantic Ocean Region West, Atlantic Ocean Region East, the Indian Ocean region, and the Pacific Ocean region.
The I3 satellites also handle Swift 64. Swift 64 is equivalent to ISDN with high-quality voice, data, and fax at speeds up to 64 kilobits per second. But with Swift 64, as more people on an aircraft connect to the system, individual data rates can slow down. So over the coming years, the I3 satellites will be slowly decommissioned and replaced with the I4 satellites.
The newer I4 satellites are much larger and more powerful than their I3 predecessors. They have increased data bandwidth and are capable of handling additional aircraft and do it more reliably.
The I4 satellites also provide true high-speed internet access. We call this Swift broadband.
With data rates up to 432 kilobits per second, a single channel of Swift broadband provides the ability to use both voice and data simultaneously, with data services mapped to specific applications.
With Swift broadband, you can have more users at the same time. It also lets you run applications like telephone, text messaging, email, internet access, even flight plans and weather and chart updates. Inmarsat services have an always-on capability, so for billing, users can be charged just for the amount of data they send and receive, rather than the length of time they are connected. That saves them money.
The satellite and ground stations communicate via 6 GHz uplink and 4 GHz downlink. The aircraft and satellites communicate via L-band transmissions, 1.6 GHz uplink and 1.5 GHz downlink. Each Inmarsat satellite is equipped with a single global beam that covers up to 1/3 of the Earth's surface, apart from the poles.
The satellites can also generate high-power spot beams. Each spot beam covers a smaller area than a global beam, but collectively they offer virtually the same coverage. The advantage is that they can quickly be reconfigured and focused anywhere on Earth to provide extra capacity when needed. When the aircraft is in flight, the satellite switches communications seamlessly from one spot beam to another, totally transparent to the user. Even if the message is broken, the satellite just resends the message in a couple of milliseconds.
Ground stations are gateways to the telephone networks and the internet. They are owned by service providers who pay a fee to Inmarsat for time on the satellite. Customers then establish accounts with the service providers to access the Inmarsat system for voice and data communication.
Each ground station has a name and an identifier number, like a telephone number. The AES needs to know the service provider's ground station number or numbers. If you have worldwide coverage, you may have many different GES IDs.
Before installing a SATCOM system on an aircraft, it will be necessary to set up an account with a service provider and give them the system identification numbers. The provider then sends the access numbers to a dealer to set up the Owner Requirements Table, or ORT.
The ORT is basically a list of options that define how the SATCOM system will work. With a charter aircraft, the owner may want to provide passengers with billable access for phone calls or internet. The account can be set up so that passengers can use a charge card and the data is automatically sent to the ground station for billing.
The Aircraft Earth Station, or AES, is the aircraft itself. The aircraft contains the SATCOM equipment along with any other equipment that interfaces with the communication system of the aircraft.
For the flight crew, the SATCOM system is like an HF radio or VHF comm, mainly used to talk to the airline or charter services company, or to air traffic control as a backup to either HF or VHF. Also, the ACARS or APHIS system can use SATCOM very much like a VHF data radio to transfer data between the cockpit and the ground. In the cabin, SATCOM provides telephone, internet, email, and other services.
The aircraft station includes the antenna subsystem, the SATCOM avionics, and voice and data interfaces.
In the antenna subsystem, a high-gain antenna transmits radio frequency signals and receives broadcasts from the Inmarsat satellites. A beam steering unit controls the high-gain antenna to direct the radio signal to the proper Inmarsat satellite based on current aircraft position. The beam steering unit gets ADIRU, AHARS, or GPS position data from the SATCOM avionics.
At the core of the SATCOM avionics is the satellite data unit, which essentially acts as a modem to communicate with the satellites.
The satellite data unit supplies both digital and analog interfaces to other avionics systems. It has multiple communication channels to support simultaneous full duplex circuit mode voice connections and one dedicated packet mode data connection. The number of channels and simultaneous connections depends on the model and configuration of the satellite data unit. The satellite data unit also provides antenna tracking and coordination data to the beam steering unit based on aircraft position and attitude data from the Air Data Inertial Reference Unit.
Some SATCOM systems contain a high-speed data unit which supports broadband communications. The SATCOM system communicates with many other avionics systems. In the cockpit, flight crews use headsets and microphones for SATCOM voice communications. In some cabins, passengers have access to wired analog telephones. Other cabin network systems provide passengers with high-speed voice and data services. The wireless cabin router provides passengers with both wireless and wired access, including Ethernet and USB ports. SATCOM systems facilitate the increased need we have for connectivity in the modern age. Both in the cabin and in the flight deck, Honeywell SATCOM systems play an increasingly important role in the future of aviation.